Let's continue our hybrid application development. And the topic for today is to get image uploading working from your mobile device to your server, and to demonstrate demonstrate how you can use the authorization and authentication techniques what we learned in web interfaces. So on both of these topics, I have a existing demo in the React Native tutorial repository. So we'll begin from the image upload. So the React Native tutorial repository what I'm talking about is this one. I will put this link to the chat, like so. So you can access it if you don't already have this one. I have made some small updates. As you can see, here are some changes made 22 hours ago. So if you already had this cloned, I recommend you pulling the latest changes to your computer. Otherwise, you will have a slightly different looking code. Might be a bit confusing. Okay, so what I have done in advance is that in my Heroku account, I have deployed two applications. So two applications have been deployed to Heroku. So image upload example server and API authentication demos. Both of these names refer now to repositories in my GitHub. So this is the first one. I will put the link to chat as well. Or sorry, the second one, API authentication demos. So this is the one which we have already been reviewing and using during the web interfaces part. This was with the JSON Web Token demos and HTTP basic authentication demos. So I have deployed that one here to Heroku with this application name. And then I have a second application which we already also have reviewed during the web interfaces, and it's this one, this image upload example server. So these two projects have been deployed here to Heroku. And this Heroku is needed because to do image upload from mobile device, we of course need somewhere where to upload it. So this is the server here, image upload example server. And what I have here on this image upload example server is that I have the Cloudinary plugin or resource activated here in Heroku. So this is all what we already have covered during the web interfaces lesson. So that is here and running and active. Let's take a quick look. What does this image upload example server, what does it contain? So here is the code. It has very short amount of code here. So this is the one what we are using in our React Native tutorial project as well. So we have this path /upload, which responds to HTTP post. And then we have the multer middleware trying to find a form field with the name image file there. And the multer has been configured to use the Cloudinary storage, so multer will automatically receive parse and then upload the received image from this with this key name to Cloudinary. And then in this property, in the request object, we'll have then the information on the from Cloudinary that how can we access the image from there. Other than that, this is just as one route for hello world, and then here we are starting the server, and here is the basic configuration with Express, Cloudinary storage for multer, and then the multer. So we can give it a try here. So this is the domain. It should respond with hello world. And now it takes a while to start. This is the nature of these free Heroku applications. They go to sleep after some time, and then it takes a while to restart. Now it started. Now when I make a request, now I get instant responses. Okay, it's saying hello world, so it is working. Okay, then let's start to see the example code on what we're going to be using. So here I have now opened the app.js. So this is the root component in the React native tutorial project. Previously, we have covered these basic styling, layout, image, icon. And last time we were practicing this navigation thing. And now we are here at step 10, this image picker, the multipart sending to server. So here I have wrote some instructions that this example code now works with this repository. So if you would like to take this into use, this project, and deploy it on your own, what you can do is that you can, for example, fork this this project. Then it becomes your own repository with the same content. And then in your Heroku account, you can then easily get your GitHub repository, the forked repository of this one, and deploy it to Heroku if you want to test this out. Of course, you can also use this one here as well if you want to. Okay, so here is our code. Let's deactivate the authentication demo. So here we have an component for this demo, image pick and send, and we give two prop values there, target URI and image form name. So here we have now the server address and the path ready to go. This is where we want to upload our images. And then here, this prop image form name, this value now represents that what should be the form field name where we are, what we are using to carry the image in the multipart. So this image here, this name matches in this repository our server code where we are in here, and here we are expecting that the file should be coming with name image. So this one matches now the value here. If you try to send from your mobile device, if you try to send images with some other field names, which your server has not been configured to receive, then, well, then it doesn't work. Okay, image pick and send. Let's see what it contains. here, this is now a class component. This would just as fine work with by being a functional component, but it has been implemented as a class component. So name of the component is image pick and send. So those are the two things what this component does. It opens up an image picker. So an image picker is a component which opens your camera album, then allows the user to select an image, and then returns to your application and gives information about that selected image. And then the second task what this component does is that it will upload the selected image to the server. And this is what we will be rendering. So there is text saying image picker. Then here is an activity indicator, which turns out that this is not actually working. But anyhow, here we have a button, and then we have a text, which says that pick a photo and start to upload. So when we click on this button, it will execute this method here, open image picker async. And what the image picker async method here does is that it will use an image picker component, which is now coming from a module called expo image picker. So this is the one what this demo is using, expo image picker. And this is how it looks like. So it gives access to the camera or roll or album, however you want to call it, on the device, and then allows accessing those selected images from your device. And then you can do whatever you want. Here is some code example. This has been written as a function, so hooks are being used here, use effect and use state. But that's React. Those are React things and not so much related to this image picker itself. Okay, so first thing in the mobile devices and mobile applications, if you want to access a resource like image album, you need to ask permissions from the user. So that is being done here. Image picker.request media library permissions async. And I'm using here this async await combination, which means that the execution of this code does not proceed from this line 17 before this operation has completed. That's basically what this async await combination does here. Okay, then when this permission has been granted or declined, the execution proceeds here. Then we check that, did we get the permission? If not, then we'll throw an error with this alert dialog saying permission to access camera roll is required, and then stop execution. But if we get the permission to access the media library, the camera albums, then we can proceed here. So image picker launch image library async. So this will now open up a view like seen here that allows you to select, allows the user to select from a nice UI an image. And here will be the result. You will see what the result looks like in the console log when we run the application. In the UI, there is also possibility to cancel the image pick. So we are checking here that was it canceled. If yes, then we again notify the user in this demo application and stop execution. If the image picker was not canceled, meaning that an image was actually picked by the user, then from the picker result, which we got here on this line 24, then we'll read the information from the picker result. And here is a little bit string manipulation done so that we have the actual file name here in use. And we'll use that when we are sending a form. And to send a form, we are doing it like this. There is a constructor function called form data, which gives you an object to represent a new HTML form. That form is known here with the post form variable name. It refers now to the object. So to this form, we are now appending a new field. And the field name will be this one. This is now from the props, which is given here. The field name will be image. And then this is the information for that model field. So here we have the URI from the picker result, meaning that the path on our device to the actual image file. Then, as a name of the file, we are setting the value file name, what we access here. And then we are saying that this is now a JPEG image. That is, if I recall correctly, this image type is also available here in the file result. And at the very least, you could decide it based on the file type name, the file name itself. But here it has been hard-coded. And then, okay, here is a foobar field for testing, another form field being added here. And okay, here we are setting a state for is submitting. This would show an activity indicator, meaning that a rolling graphics on the screen while it's processing, but it turns out that it's not being shown. So this is now irrelevant here. Then in this code, we are using the Axios library. So Axios is a promise-based HTTP library, which allows you to send HTTP requests the way you like it. And this is something what we have been using previously, at least in web frameworks course. So I think you are familiar. So Axios works like this, that you define that, okay, I want to send a get method to this path. Then here is some information then there, and then we'll get a response, or we'll get a response error. And it's also possible to do with the async await, like you can see here. So await Axios get, then deal with this. So this is the promise type of syntax, where this method will return a promise, and a promise in JavaScript always has these then and catch methods, and then you can chain these promises together if you are returning something. So this async await is another way how you can deal with promises. Introduced in ECMAScript version 2017. So it's been already around for some time. So this is the Axios library, which is used here to send. So last year in this course, there was a surprising situation with this Axios, that about 1/2 of the students in the class, for some reason, their device did not work when it was executing code which was using Axios. So no HTTP request was sent. And then for another half, it was working just fine. And my phone was included in that half. So here in this example, we are using Axios to send an HTTP request. But then here in the tutorial step 11, we are using something known as fetch API, which is a JavaScript API to send HTTP requests. The reason why I do not like these fetch APIs is that it forces me to write extra steps. And that step is here. It forces me to convert the response to JSON objects, so it forces me to pass the response. So I don't like that, and I much better like to use the Axios. But it turned out that for some students, the Axios code does not work. I have now tested this on my two devices. I have an iOS device and then I have an Android device. And on both of these devices, this Axios was working. But if you have some very strange problems that turn out that there is no HTTP request being sent, so then it might be so that this Axios is not working for your device. Also, there might be a chance that all these problems are a thing of the past if they have somehow updated the Axios to work with now with all environments, including those which have had problems before, but I don't know the situation. So just so that you are aware that this might cause you some problem. If so, then you will need to convert the Axios to use the fetch API. This will work with all the devices. Okay, but in any case, the main thing here is that we create a new HTML form using this form data constructor function. Then we set a form field there with this name and this value. Then we'll send an HTTP request to our URL. This target URL is now in my demo, it is this address. We'll send a request there and we'll have the post form, this form data object that as part of Axios data. And then what we need to do is that we need to set to the headers, we need to set content type, the multipart form data. And then if everything works great, we'll have a success. And we'll get a message saying image upload completed. If there was some problem, we'll get a message saying that image upload failed. So this is the demo what we'll execute soon. Do you have any questions about the code?
Nope.
Okay, I will set up.
Yeah, you could reset the type, I guess, to include like PNG files also.
Yes, if you have a PNG file, then you should definitely set here PNG. Yes.
Yeah, cool.
So a better option would of course to be read from the file name or from the file information what you get this picker result. You can check out that does it have the file type there. So doing it like this, that you hard code this one is not maybe the best option, especially in the long run. So the main thing when you are programming this mobile application with the React Native, if you have the intent of interacting with the server, the main thing is to keep clear that what is it that you are doing. So basically, if you have been previously using Postman to send those requests, now that is your objective with the React Native code, that you replicate the same sequence of events and things what you do with the Postman, and now just with the code. So in Postman, we create, or we choose this multipart to be the type what we are sending. Then we use the correct field name. Then from the Postman UI, we can select the file, and then we can click on the send button to send the post request to our given URI and so on. So that's important, and that's also an important thing to keep in mind when we are doing the next thing, doing the JSON Web Token authentication. That has quite a few steps which must be implemented in code. So if it seems complicated or you are overwhelmed, I think the main thing is to try to keep a clear picture that what is it that you are trying to do. and then try to analyze the example code or write your own. So that's about that. Yes, the web token thing. Let's get this one working first. Why is it showing this one? Did I not save my changes to app changes? Right, no. How come did it already crash? So unstable. This is a strange thing. I don't quite understand why, when we are using this USB connection, why is it so super unstable, the connection to the device? When using the Wi-Fi, I have no such problems. It's like it has some very short timeout for the USB debugging or something. Okay, now it's running. All right, so here we have the code. Let's see what's going to happen here. And I will activate this debug remote JS, even though it makes the execution super slow again for some reason. But maybe we'll benefit from that one. So when I select the image, we print out to the console the result of that big operation. So now I will click on the button and nothing happens. It is remote debugging. It usually takes a long time to respond. Okay, so now here is my photo library. I have already previously given permission to the application, so it did not ask again. Now I choose here an image, and it is now uploading it, which is proceeding again slowly with this USB debugging I mean, there's remote debugging enabled, but now I got the message that image uploaded completed. So here, this first printout, this one in the console is now the result of this console log at line 25. So this is the picker result. So this kind of information we are getting from the image picker component. Cancelled, height and width of the image, type, okay, image, and then a URI. So here is now the URI for the image on my device, the path where the image can be found. So as you can see, what this is doing, that if you read where is this, okay, data, user, cache, experience data, anonymous, React Native tutorial, and then it continues image picker and so on, so on. And then there is some the file name itself. So based on this path, you can see that the image picker will actually copy the selected image to this temporary location in this application data folder. So it is this URI does not point to the actual camera roll, but the image picker component has copied the selected image to this temporary location where it is then available. And the image type could be deduced based on the file type, which there at the end it says .jpg. That is where you could get the type, this one. Okay, so then now what we are seeing here on the screen, image upload completed, that is the result from here. Before that, we got the console log response, so we can see what's happening there. Okay, it doesn't hang up. So this printout here in the console, this is coming from here from line 52. So we can see what the server is responding to us. Here in the data, the server is responding to us with this. So this is not the exact information what was given to my Express code in the Cloudinary. Now you can see here we have a URL. We have a secure URL with HTTPS. I can copy this one. And now I can access it here. And there is my image. This corner looks great. So that's it. It is demonstrated that we can select images from our mobile device with React Native and the Expo image picker, and then we can upload it to our own Node.js and Express-based server, receive those, and then forward them at Heroku to a Cloudinary and then use it. Of course, in a real application, the server would not return this information to the mobile device. Instead, the server should, of course, store this information or parts of this information to its internal storage, where it's keeping information that, okay, now this picture belongs to this and this posting, this and this item. And then your application should request when it, for example, wants to show that, okay, show now this posting on the mobile device, or show a list of these posts, for example, or bicycles here in Oulu. So then it should get a list of these posts, and all those posts should have then URLs like this there, so that then in the React Native application you can draw them on the screen. So as we learned earlier, that with these images, when you have an image element, there is the source prop, and then here you can put an object with URI property, and then an HTTP-based URI, and then the image element will load that image from the public server from the internet and then show it. So this is the address what you could then put to the image element in your mobile application. And this Cloudinary is a great service also for that, because as you can see here, we have quite a big image. So its height is 4,608 pixels, width is 3,000 456 pixels, which is pretty big. And when you are displaying images on your mobile device, especially some smaller images on the UI, there is no need to load the image at this size. So the Cloudinary has, let's see if I can find it. It has been a while when I checked this out, but we can request in the URL in this way. As you can see, you can give information here that what is the size of the image what you want to get. So you can also get this kind of crop so that it will make a round automatically for it, and so on. So transforming media assets using dynamic URLs. So when you have the public ID for the image which is stored in the Cloudinary, which is given here, this is the public ID. So I could then run an image transformation. So let's give it a try. So it will formulate our URI a little bit. Here is our secure URL. Cloud name is now this one. Asset type is image. Delivery type is upload. And then version is, I guess, this one. Version is this one. Public ID would be this one. And extension is this one. So now we could add these transformations there. So they come before the here. So let's see what we can do. We can do transformations, transformation parameters. Let's see, where is the transformation? There is rotation. Maybe we want the resize. Where is the resize? We just say width or height. Okay, resize the image to height of 150 pixels while maintaining aspect ratio. So it would be this one, Z scale H150. So if you put this one here, like so. Yeah, so here is now my image in a smaller size, height 150 pixels, and this resize is done by Cloudinary, so there is no need to load the huge amount of data, which it would come if we don't have the scale, if it's in original size. So this is the over 4,000 pixels. So if we are only going to show a small thumbnail of it in our mobile application, you can do it here with Cloudinary, these dynamic URL parameters, do the transformation. So I think this is a pretty great service on the Cloudinary part, and very useful doing these mobile applications. Without this, it would be your API, which would, for example, need to create a couple of resize versions of the image for the application, or perhaps your mobile client application. So this is a very good feature, which I recommend you to take advantage of in your application, because I don't see a situation where you would need to show an image with this kind of resolution, whatever is the resolution what your camera is giving out, but this is way too much for any mobile application. This is much more closer to the reality. And then we can change here. For example, if you want, let's see, width of, let's say, 400. Now we have a width of 400, and we don't need to transfer any extra pixels, which in the case of mobile application always takes some time. Never mind how fast is your connection. Okay. do you have any questions about this image upload thing?
Yeah, can you hear me?
Yes.
Yeah, I was thinking like if you have like a application, like maybe not our application, but some picture application, and then you would have like smaller images, and then you like click it, and then it would be become a bigger image. Like, would it be better to have like that it gets the another image on that load, or like should you load, or like if you want to have like you have small image and then you would have a bigger image?
Yeah, well, I think it depends on the situation.
Yeah.
In any case, you will need to end up loading images at some point, more of those. Because if you think about, for example, an application like Instagram, where you basically have an endless supply of these images.
Yeah.
When you are looking, for example, some hashtag or just browsing the feed or something. So there is basically endless supply of these images. So at some point you need to load those images. So then the question maybe becomes that do you load them individually or do you load them in some kind of bunches, so in groups?
Yeah.
But yeah, of course, there are situations or application types where you could load all the image content in one go if there is not a very large amount of those images. Then the UI would be very responsive, of course.
Yeah, I was thinking like if we had like 6 images, and like if
Yeah.
we had like the inventory, like you could load the 6 images in that.
Yes.
But then you are like loading all the, if you're looking all the items, then you only load the small images for the query, like.
Yes,
Yeah.
yes.
Yeah.
That is what you can do. Yeah.
Okay. Yeah.
I have a question about the image type. So what if you wanted to upload a GIF, or is there a way to upload another type of image type? Because right now you have only JPEG there, but if a person wanted to upload a GIF or a PNG, is multiple image type also possible?
Yes. You just need to put the correct image type.
So you can have more than one type there.
Well, one file has a single type. So you must use the type what your file has. So but there is no rule in or why you could not use. If you are having a GIF image, what you are uploading, then the image type to be this GIF. If you have a PNG image, what you're uploading, then use the PNG.
All right, thanks.
Yeah. Yeah, so the challenge when doing something like this is to get both of the parts absolutely correct. So getting correct the client and getting correct the server, because if you have an error in either one of those, then it doesn't work. And for that reason, I think it is good if you already have the web interfaces exercise what you have done, if it's already working, and you know that it's working because you have tested it with Postman, for example. So if it works with Postman and you can validate that one that it actually works when deployed to Heroku, then when you have any problem, then it becomes easier because then you are pretty sure that the problem is in your client side. But if you are developing both of them at the same time, then the error can be anywhere, and then the problems can be more complicated. Okay, let's have now a break of 15 minutes and then continue with the JSON Web Token an authentication demo. So we are now at 12:48. So if you have a 15-minute break or a couple of minutes extra, so we'll continue at 13:05. So break until 13:05. We'll continue then. So JSON Web Token authentication is next. And here it's really important that you remember what we are doing. So if we have here, let's say, route A, which is unprotected and available to all, then we have route B in our API. Which is protected and available only to users who logged in. So this is the situation. So this is on the API side. Then on the mobile client or mobile application side. So what you want to do here is that you have views which are available to users who have not logged in. And then you have views which should only be shown to users who have logged in, and user-specific information is shown. So this is typically the situation what you have. On the API, you have routes which are unprotected and available to all. And then you have some routes which are protected and available to only the users logged in. Typically, we are dealing with user-specific data with these routes. And then same thing on the mobile application side. We have views which are available to all users who are not logged in. And then we have some views which should only be shown to users who have logged in. On certain applications, we might have only these, or these, or sometimes we have both of these. So deal with this protected route. When we are using JSON Web Token, what do we need to do to access protected route B if we have totally clean situation without any previous interaction with the service? You remember what are the phases? It's protected with JSON Web Token. What must be done to access this?
Yeah, so first we need to somehow get the token. So maybe we would have like a basic authorization system, and then the API gives us a token what we can use, then show the protected route. That
yes,
yeah, we have this token and it is valid for this.
Yes, yes. So we will need to have a login of some sort. And this login, we will give our username and password. And as a return, the API gives us JWT token. Use the JWT to access protected routes. So this is the thing what we must do. Okay, now if you think about the mobile application side, what should happen with this part? How would you deal with it? On the mobile application, this should be shown as a login view where the user can write username and password, right?
Yeah, if you feed that back to the API, and then if it returns back the JSON web token, then you can use that.
Yeah. So we must have a view to do login. On the mobile application, we must have this login view. And login view, which is used to send username and password to the API. Then in the response, the API gives us the JSON web token. What must we do here on the mobile application side then? We get the JWT as a response. And what is done with the JSON web token?
JSON web token is returned every time you try to access one of the protected routes. So you might save it somewhere.
Yes.
Not as a file, but somewhere in the code you might save that.
Yes. So save it for later use. So we must save it for later use, and then we must use it when we access these routes. So then we use the JSON web token when we are accessing these views. And then in a real application, we would also need to have a register view, which is used to create a new user. So here we must submit at least username and password for the server to store. Okay, so there's quite a lot of things. We must have the register view. We must have submit user information to the API, registering. We must have login view. We must have the capability of submitting login information to the API. We must have the capability of save the JSON web token for good, because we must have the capability of, when JWT is saved, do not show login view at all, right? You do not like an application which requires you to log in every time when you start it, except if the application is some kind of banking application, not super secure application. But if it's your Instagram or Facebook or eBay or whatever, those applications for good user experience, they do not request the user to log in every time when they start the application. So we must somehow save JWT permanently. We must have this capability, and then our application must have the capability of not allowing user to view views without logging in at least once, and then we must have the capability of in protected views to access user data from APIs, must be able to send JSON web token with the request. As you can see, there is quite a lot what the mobile application must do. And understanding this whole process is critical if you want to implement it. If you don't understand this whole process, well, then there is no chance of you implementing it, no matter how much copy-paste you do. So that's the reason why you must first understand that what is it that you are doing, and then we can start to think about, okay, how do I do these individual things? Now, one more thing before we go to the implementation of the mobile application thing. Do you remember what was important thing regarding how the JSON Web Tokens are generated, validated on the API side? What was very important thing there to consider? Do you remember or do you know?
Is it the secret key?
Yes. And now, previously in our example code, what we had, so the secret key refers now to the signing key, the key what you use to sign the JSON Web Tokens, which is the secret key. So now, previously in our code, we had let's see, where is it? We had a JSON Web Token secret key like this, and then it was coming from a file called jvt-key.json from previous version of this same example code. Maybe you remember this. Now I have modified this part so that it does not have to come from a file, but it can be also in the environment variable, no jvt key. So now I have modified this so that if this is present, then we will use that one for the JSON Web Token secret key. If this environment variable is not present, then we'll try to read it from the file. And in Heroku, how to deal with this environment variable JSON Web Token key, if you want to deploy your application, API application to Heroku, and then you use the signing key so that it is not stored in your version control system. In Heroku, you set these, I think. Yeah, in Heroku, there is something known as config vars. So here, I have declared this JVT config vars. Here is it. Here is the value, my secret key. These config vars in Heroku, they are available in the execution environment as environment variables in Node.js. So here is my config var name, JVT key, and I can read it in my Heroku code from the environment like so. So this is an important detail regarding Heroku deployment. Okay. So this is what I have deployed to Heroku already. And just as a reminder, how does this work is that here we have a path which we can use to register new users by giving their username, password, and email. And then we have the JSON Web Token part here below, and we have two routes to deal with this kind of to-dos. So beyond showing just this API authentication, this application also has a very simple to-do application implemented. So this to-dos JVT, when you get, it will get all the to-dos from user, which belong to user. So there can be multiple users in the system. Each user have their own to-dos. So a to-do list, get milk, learn programming, and so on. So from this route, I can read the to-dos of this user. Then from this route, I can create new to-dos. And both of these routes are protected. JSON. To access these, you must have an existing user, and then we have here a login path with the JSON Web Token. This login path is working with HTTP basic system. It means that the username and password, which are transmitted in the login, are transmitted in the header, in the field called authorization. And they go as base64 encoded. So this one is needed to get the JSON Web Token, which is then needed to access this actual application routes. So the application what I have here is step 11 JSON Web Token auth. It's a simple application which works as a to-do application where a user can store some to-dos and then read them later on. There is no functionality to mark them done or not done. Simply like a list where you can write stuff. It shows you the basic things. And it's this API auth demo component which contains all the functionality to this application. There is one API URI, which is now the address of my API account. Okay, let's see what the auth demo is made up of. Here we have a semi-large amount of code here at auth demo. Before going into this details of this code, let's see how it looks like on the mobile device, so that it's easier to understand what is happening. And while doing that, you should keep in mind that these are the things what we are going to see here. Okay, now it's hopefully going to show what it looks like. No, saved. Okay, I'm going to disable the remote debugging. It's already logged out. Okay, here is where the application starts. So this is what it will show. So we need to have the register view. That's here. So here I can write username, email, and password of a new user. And that we will deal with this one. Then we need to have login view, which is this one. And this login view will take care of this. Also, what will happen is that when I click on the login, this will happen. I'll save the JSON Web Token for good. And then, as you can see, I have no way of accessing any view beyond these before I have logged in at least once. When I want to log in, I click here. Now my application sent my username and password to the API. As a response, I got JSON Web Token, and now it has been saved. And now here in the application content, I can now use the JSON Web Token whenever I want. This has a couple of views. It has this kind of main view, which is application content, and just you have successfully logged in. Then I can go to see my to-dos. Get milk. Now when I click on the save, it will access my API routes, send a post request, and also send a get request to read the current values here. Get milk. React Native and APIs. If I go back here and go there, they still exist. If I restart the application, reload, something went wrong. And okay, unbelievable. It's not even restart. No, okay. Again, starter method, I guess. Okay, let's see. Okay, so now it started the application, and the thing to notice here is that it did not start in the login view. It started right away here in the application content. So it automatically detected that we have an existing JSON Web Token. So login view does not show at all anymore. Instead, it goes directly to the application content. And now here I might have still the to-dos here because they are now saved in my API, in my server. So this is the functionality of the application. And I can log out, which will erase my JSON Web Token. Here on the console, you can see some activity happening. This is the demo application. So it has a couple of views. This login view, registration view, and it has this main view, which just displays this one. And it has this to-do list view, and that's it for the views. So let's see now how it has been implemented. Everything is happening inside this auth demo component. What is this rendering here? You see first that here on the render part, we have a navigation container and stack navigator, and then we are rendering the output of this auth logic method, which has been defined here. What this auth logic does is that it declares a couple of constants called auth screens, and then here is another constant checking for token storage. And here we have an if statement which decides what should be displayed. If the application state is that we are checking for token storage, then we return this view, which is declared here. So we have a loading screen. It doesn't really show up, it's so fast. Then, if we are not in the state of checking storage, token storage, we are here. And here we are checking that do we have an active JSON Web Token stored in the application. If we have, we are going to return this app, which was declared here. So it has a bunch of screens. If we don't have this active JSON Web Token, we're going to return these auth screens. And that is now what is being shown here. So the auth screens are made up of this user login and sign up screens. So let's see how do these auth screens look like. So yeah, before going there, that's what this auth logic does. So it returns these screens that should be displayed. So auth logic function or method is executed here. And every render, the auth logic is executed. And depending on the application state, this one will return different set of screens for the navigator to render. And now where we are showing these auth screens, and it has been declared here. The auth screens look like this. It has three views. It has the login, this one. Then it has the sign up, this one. And then it has the sign up completed. You do here. Example. And then 1, 2, 3, 4, 5, 6, 7, 8. And sign up. This is the sign up completed. So auth screens is the set of these three screens. And these auth screens are shown when we are not checking for token storage and we don't have an active JSON Web Token in our application state. So in that situation, we show these auth screens. So the idea here is that we are selectively rendering different views for the application, depending on the application state. Okay, so now here in this login view, here, this login view will render this login screen component, this one. So this login screen is now what we are seeing here. By default, I have hard-coded here tester and tester password, so that I don't have to write them off every time. But the other users also work. For example, I have now the example user. And password was this 1, 2, 3, 4, 5, 8. So now when I click here on the login, this username and password, which are stored here in the state, as books, will be used, and a login request will be sent API to this path, login for JSON Web Token. The get method, and it needs in the header, it needs the authorization field with this value, basic space, and then username, password, base64 encoded. Right? So this was decided in our API, how it should be looked like. So then I send the request. If I get a successful response, this is now done by the fetch API. Okay, now I lost again the session. Oh man. Well, anyway, so this is only the fetch API. So here is an extra step required. This fetch API. This is the reason why I don't like this fetch API. But here. Okay, so this is the code what is executed on a successful situation. I have the token, so I'm going to pass it for application state storage by using a method which was given to this component via the props. So this is the standard mechanism in React how you can pass data upwards from components. And this onLogin receive JSON web token JWT is declared here in the auth demo. Here onLogin receive JSON web token. It is here. Here I will get the JSON web token, and what will happen is that I will use a component called secure store, and I will store my token there with this name, which has been decided here, demo JSON JWT2. This secure store is also an Expo module, Expo secure store. So it offers similar kind of storage as what you have, for example, with local storage, except it's secure. So no one outside the application should be able to read it. So my JSON web token is stored there. And in addition to that, it also stored in the application state. Here with JWT response set to active JWT. So here is the part where we are. Sorry, we're in the component mode. So secure store set item async. So here we are storing with this name, this value. And then when we're ready, then we set it to the state, and then when I click here, now it changes views. It changes views because now we have an active JWT. As you might remember, when you change the state of a React application or React component, it causes a re-render, and there is a rendering function. So this auth logic will be executed again. It is here. So auth logic will check this if, okay, we are here in the else statement. Do we have an active JSON web token value in the state? Something else than null. Yes, we have it. So we're going to return app. And this app is now seen here on the screen. It's rendered by this screen, and here we have to-do app. So everything what you see now here is responsive made by this to-do app. And this to-do app will receive the JSON web token. It will receive the address API so that it can deal with the to-dos, read and write those. And then it has a function which can be used to do the logout. So this function will be executed when I click here on logout. And on logout, let's see, when I click here, logout, this function executes, and what happens is that in the state, active JSON web token value will be set to null, and from my secure store, I will delete the item, so the token was stored there. Because we modify the state, it will cause re-rendering, and auth logic will execute again. So auth logic now will again make these checks. It will be here in the else branch, and it will check that do we have a JSON web token? No, we don't. So therefore out screens, meaning this view is shown again. And now again, when I click on the login, now we will get a new JSON web token, which is stored. And therefore, this one will be on this app, simply is this to-do app. So this to-do app then, what does it do? It has a little bit of code. It's also a class component, so it stores the state. In the state of this to-do app, we are storing the to-dos. And in the props, we have received the API URI, and we have received JSON web token, which we can then use. Let's see first what is happening here, the rendering. So this is what we are drawing. We are drawing here, again, a new stack navigator, which has two screens, view 1 and then to-do. This is the view 1. When I click on on this button, go to to-do list view. Then this navigator will switch to this view. Now we are displaying this one. So now here we are, this component we are passing the to-dos as props. And then we also have a button pass on to-do add. So when I write here, bar, if I click here save, now this one gets called. And this is what happens. So here is again the fetch. It's a very big amount of code because there are these extra steps, for example, this one. And I send this HTTP request again to my API. I want to write a new to-do, save it to the API. So I send a post to this one, indeed a post. Here is where I set my JSON web token. So again, authorization field, value bearer, and then space, and then my token value, which I have saved into the application state, and passed to this component via. And then in the body, I'm putting the information what I'm saying, writing here. So this value here in text is the description, and then due date. Okay, that's automatically generated. It's a fixed value, not implemented here in the UI of the application. And then this part is simply dealing with the response. So here I get the response, and I will update the state. This to-do app with the response here. So as a response to this post, I will get a new list of these to-dos stored in the application, in the API. I will update it, and therefore it gets updated here in the screen as well. Click here, save. This updates because of this code line 67, where I modify the state in this component. And here are the to-dos being stored in the state. When this component starts, meaning the whole component which deals with this logged in view. So when the component starts, it executes this one. So getting to-dos prints to the console, then sends an API request. This path, this method, putting this to the header, again, authorization bearer. And then response is JSON, list of JSON elements, or an array of these objects, these to-do objects, and that save it to the state, and therefore it can be shown here in this component. So even for a simple application like this, there is quite a lot of code and quite a lot of things happening, and that's the reason why in the beginning I tried to emphasize that to understand what is happening here, you must keep this in mind and must understand that what will be happening with the API, because you will need to do that. And then in addition, you will need to do the things required by the mobile client, meaning that you need to save it, and then you need to keep showing the login views if you have the JSON web token saved. And then you will need to deal how you keep track of the application state to update the UI. Yeah, it took almost like 1 hour to go through this. So it can be a lot to digest, I'm sure. But hopefully this example code together with the explanation what you will now have available as a video format for this lesson. So hopefully that will help you to gather the pieces. Do you have some questions now, or did I totally lose you?
I just want to check. So the login screen is a child of the auth demo screen. Is that right? And it's receiving the token.
So the auth demo is sort of the root component of the whole application. And the auth demo here is storing the JSON web.
But it's receiving the web token from the getting passed through the props in the login screen. Is that right?
Yes, because this auth demo is what this is doing is that this auth demo is storing the JSON web token, and then it is managing the logic that what is being shown here in the application. Is it these login screens or sign up screens, or are we going to show this actual application content? So that's the task of this auth demo, so this root component. So it stores the JSON web token because the JSON web token is needed in the child elements of this auth demo, which are now these actual content views. So how the JSON web token gets passed to this auth demo? So that is through this login screen. Is this component, which is now actually here displayed on the screen. So this login screen is now the thing what we are actually seeing here. This login screen is now a child component of this auth demo. So therefore, when this login screen wants to pass the JSON web token, what it receives here, when it wants to pass the token to the parent component, this auth demo, it does so by calling this function which was given to this prop. So this function call is defined here. So when we are defining the login screen for the navigator, so login screen, and then on login receive JWT. So here we define that this function, there shall be a prop with this value. This now is a function which has been defined here in the auth demo. So the auth demo will deal with the secure store, and then will save to its own state this JSON web token. I don't know. Did
yeah, it makes sense. It's just you really need to stay awake. But
yeah,
it makes sense.
I know it's a pretty complicated and difficult to follow when you're looking multiple components from someone else's code.
Yeah, could you use the secure storage, like when you get the token, to store it immediately, and then get it from when you need the token and get it again from the secure store?
So you mean that it would be read every time when it's needed?
Yeah. So like you wouldn't use the state, or like but then
I guess so that it could be done so. Then this state variable would need to be replaced by some kind of Boolean value that we have the token or we don't have the token.
Oh.
Because it controls which screen is shown. But yeah, probably it would work so that you could read item from the secure store.
Yeah, or like you could check that if there's
well.
Yeah, like if you have anything in there, because you are emptying the secure store. So like you could check like if there's anything stored there, that secure token name.
Yeah, so the secure store is emptied when we do the logout here.
Yeah.
And then when this auth demo loads up, first thing what it does is that it checks out that do we have the key stored in the secure store. If so, then it is immediately set to the state here so that these screens are not displayed and the application goes immediately to this view on start. But if the key does not exist in the secure store, then the application will start by having this one visible. But yeah, it would probably work so that you would access the key from the secure store every time when you need it. I think it would work just fine. I have just written this way.
Yeah.
All right. Any other questions?
Well, I'm not like which one would be this like like is it like user-based token or is it just this client-based token, this app, right? Because you are saving it there, like you are verifying that the user is logging into this client or this app. But then, like, if someone could steal the token.
Yeah. So yeah. That's the idea with the tokens, that if somebody manages to steal the token, to intercept it somehow, then that person can impersonate you.
Yeah.
As long as the token is valid. And for that reason, when you're implementing these tokens in the APIs, it's a good idea to make it so that the tokens are not valid forever. Yeah. Instead, that they have some fixed time which they are valid. For example, 1 day or 2 days or a week or so. And then if the token expires, then the application would, in the background, silently would make a refresh token. Make a refresh token operation, and that can be done so that when the user does the first login, then a second token called refresh token is also returned, and then hopefully the bad attacker doesn't manage to get the refresh token as well.
Yeah, when I was reading this, like some apps do, like there's like a client token when you install it, and then there's one with the user token, and then there's something like they compare the both. I don't know, like there was a lot of stuff like interesting about the security itself. Like
yeah, you can do lots and lots of different variations. Yeah, but I have to say I'm no security expert, so
yeah.
I can't like explain all the possible variations or all the details. There typically are dedicated persons who are focused on this. And for example, in our school, from the teachers, Teemu Korpela is very security focused.
Yeah.
So if you want to discuss about details of these different token variations, I think Teemu has a lot more knowledge beyond my knowledge.
Yeah, he did teach, like I think it was first year when he had the Linux and stuff and other stuff too. Yeah. Yeah, but I don't think. Yeah, I think this is clear for now. Only the do is to get everything working.
Yeah. So here about this navigation, what we did last time. So this is now new thing. What is this critical for this whole thing to work as well, so that you realize that you can change the views what the navigator is showing based on some logic, based on some state. So that's the key on managing that the user cannot access these views before he has logged in. So this is one way to do it. The rendering is physically changed depending on the application state. And then regarding these parts where we have the to-do app here when it starts, so you must really keep in mind that what you are doing and what are each thing, why are they there, and what is their purpose. When you understand that, then it becomes easy to piece together the operations what you need. For example, that okay, I will need to ask from the API to get my data, and then this code. It looks quite a big chunk of code, but this is simply the fetch API, making an HTTP request here, and then deal with the JSON Web Token. This is done manually. There could be some libraries which could deal with this, or you could abstract this operation into an own component as well, so that you don't have to have every time so much code, every request, that you could do it more easy way. And then the details of this JSON Web Token headers could also be omitted from every request. Now when these requests are done like this, that all the details are done for every request, then it's easy also to make mistakes, because this is something what always needs to be there. So having this one hidden in some own small module could be beneficial in making the code more easy to read, and then also maybe decrease the amount of errors that if you forget to put would not get I failed access. As you can see here, we have again almost the same kind of code what we have here, so there's quite a lot of duplicate code. I have it here so that you can get a nice printout to the console. So this printout here, it helps in hopefully helps in understanding what is happening. But if you don't need all these different console logs, then hiding these into some own modules would be easier. Okay, so that's it. That's basically all the prepared content what I have for this whole React Native thing. So from now on, all the lessons what we have, the lesson times will be focused on helping you to finish your graded exercise and to solve any problems what you might encounter. So for today, we still have a couple of hours remaining. So if you want to stay around and start doing your graded exercise work, feel free to do so. I will be here, and if you run into problems, then we can discuss about those. But beyond that, I will now close the recording. No more teaching of new content coming. So all our topics have been covered now. Now it's just for you to apply them in your own project. Stop recording now.